Good morning, ladies and gentlemen. This is Mr. Strassel here. Well, it could be good morning, or it could be good afternoon, or it could be good late evening, whatever it is, whatever time it is that you're watching this video. Good, good deal for you. Let's see here. This is our first of many videos, it looks like. Draw a little happy face here because we're like happy. Now we might be a little sad because yes, I do. I miss you, but it's going to be okay. So I will see you soon. So today we're going to have a little video to assist you with the IXL Algebra 2 standard N4. This is a very important standard because down the road there's going to be a couple rational expressions IXL standards that are going to get difficult. This particular standard is not too bad. What we're going to do, and we've been doing this really all year long with the regular fraction, is just factoring and cancel, factoring and cancel, factoring and cancel. So let's do example number one right here. In example number one, what I want to do is simplify that rational expression. Here's what we're going to do. We're going to factor the bottom. The top is already factored, so we're just going to leave it as x. And I see that the bottom only has a common factor of x. So I'm going to factor an x out of both of those guys. And x, what times x is 3x squared? 3x. What times x is negative 4x? Negative 4. So I'm going to take this factorization and put it on the denominator over here. 3x minus 4. And now I can see that these x's will cancel. Keep in mind you can only cancel factors. You cannot cancel add-ins. You can only cancel factors. And here I have a factor here. I can cancel those, so the simplification of that particular rational expression is 1 over, because once you cancel x over x is 1, is going to be 3x minus 4. Sweet! Next example. Here's one. Oh. Same deal here. We're going to factor and cancel, factor and cancel. So it looks like this, the bottom, there are no common factors on the bottom, but there is a common factor on the top. And it looks like I had to do some investigation. It looks like that common factor is 2x. It looks like it's 2x squared. It does indeed. So what do I factor out of 4x to the fourth to get 2x squared? Looks like it's going to be 2x. 2x squared times 2x squared. This one may not factor. And 2x squared times 1. So this one doesn't factor, so I would write that this way. I have it factored out, and this is actually a nice example, Lee, because there are no common factors here. People may want to factor those ones. Do not do that. And let's see, that's correct. If I adapted this problem so that there would be something to factor, let's do this. I think the IXLs are always going to give you something that will indeed factor. Let's rewrite this problem, and let's write it this way. Let's go 4x cubed minus 2x squared over 2x minus 1. Now if I factor this bad boy, I'm still going to factor 2x squared out of the top. And what do I have here? I have 2x minus 1. And we need to check that. 2x squared times 2x does indeed equal 4x cubed. 2x squared times negative 1 does indeed equal negative 2x squared. So this is indeed the factorization. And if I look on the bottom, I'm not doing anything with this 2x minus 1. And if I look, and this is hard for elementary algebra students to realize, this whole great big thing here And this whole great big thing here, these are factors. They're exactly the same. That's a factor. That's like factoring up above. We saw where we canceled the x over x. Here we're going to cancel the 2x minus 1 and the 2x minus 1. Those are both factors. And so what ends up on the bottom, because this is 2x minus 1, you don't see them there, but that's a times of 1. So once I cancel these rascals, what do I have? All I have left is a 2x squared. What? That's correct. All right, next problem. We're about 5 minutes. I'm going to try to really limit these short videos to about 15-20 minutes. It works best with the internet, works best with you guys. And let's go to the next page then. I think we're done with this page. We are. Let's go to the next page. Ooh. Hey, we should be able to do this one good. Keep in mind what we're going to do is simplify this rascal. How are we going to simplify? We are going to factor. And then we're going to cancel like factors. We're going to factor and cancel. So I need to factor this top thing, x squared minus 2x minus 35. And to start off, some of these factorizations are going to be pretty easy because we see here, if I look at that, to review the AC method, a times c is negative 35. And a plus c would need to be negative 2. And right off the daggone get-go, I see that that's going to be 7 and 5. This is going to be, it's going to be negative 7 times 5, negative 35. Negative 7 plus 5 is negative 2. So since a is 1, I can go right to the top of this rascal is going to be, actually going to be on the side, a nice review of factoring quadratics. It really is. So let's see, right off the bat, since a is 1, and I have the p and the q, it's just going to be xp and xq. It's a nice factorization. So let's factor the bottom thing. Ooh, I see it immediately. Without even looking, I can, well, you have to look at it, you silly head. Without much work, without even going over here and doing the AC, I see immediately that negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. I saw that almost immediately. So I'm going to go x minus 3 and x plus 2. And again, what do I have? I have something that doesn't factor because doesn't cancel, sorry. So this is a reduced version. Let's see here. Let's check the work. Let's check the work. X minus 7, x plus 5, x squared minus 2x minus 35. Yep. And this is correct. So this one, these are actually really nice problems. This one doesn't cancel. I did factor it, but it doesn't cancel it. So I wonder how we can turn this into a problem that does indeed factor. Well, let's see here. Here's what we're going to do. We're going to write a whole new problem over here. And on the bottom, I'm going to leave this easy rascal here. And I'm going to create a new one on top just for giggles. And the new one on top is going to be x plus 2 times x. Let's use this x minus 7. And what's that going to be over here? That's going to be x squared minus 5x minus 14. And I see that because x squared, negative 7x, plus 2x is negative 5x, negative 14. Now, if I were to ask to factor and cancel this guy, it's going to be pretty easy. I already have the factorizations here, but I want to show you how this cancelization works. And you have to realize that sometimes it's not always going to reduce or cancel. Sometimes you won't have factors that cancel, as this example. So let's try this guy. Well, I know this factorization on the top over here is x plus 2, x minus 7. And I know already the factorization on the bottom is x minus 3 times x plus 2. And right there I have it. I have this x plus 2 and this x plus 2. Those rascals are like factors, so we're going to cancel those. And we have the reduced version of this rascal, x minus 7 over x minus 3. Some very good examples. This example, you factored, nothing canceled. That's okay. Still a smiley face. Here I factored, and I did have like factors that canceled, which gave us this guy right here. I think there's one more. Here's one. Here's another example here. Oh, this one. Why would you go to this easy one? Well, every once in a while you need an easy one. The top one is easy. We're going to factor an x out of that rascal. There's only one thing to factor. What times x is x squared? X. What times x times what is 5x? 5. I bet this one doesn't factor either. Let's factor a 2 out of that rascal. Let's see here. 2 times what is 2x? And 2 times, 5. It does. It does indeed. Look, here you go. Here's your like factor. X over 5 and x over 5. A lot of people they do all kind of weird things when you can only cancel factors. And here's my like factors. What's the answer? Pause the video. Pause. Yep. X over 2. Woo! You betcha. Let's do one more example. Keep in mind, if you can do these, it's going to be a good idea to watch these. This will really help you with the IXL. And there'll be another video tomorrow over the next IXL. I don't want to do that problem. That's too hard. Let's go back here. Let's see here. No, we have to. Okay. All right, we have to. Boy, looks like this is going to be a tough one. Maybe not. Let's make it easier. Let's just start factoring this by steps. First thing we're going to do, I see that, let's see, the top all has a factor of 3. The first thing I'm going to do is factor this greatest common factor out of the whole trinomial up here. I'm going to factor a 3 out of that. That's going to be 3 times x squared is 3x squared. This is going to be a 10x, 10x, 3 times 10x is 30x, and let's see here, 3 times what is 27? 9. Heck yeah. And so on the bottom, let's factor a 2 out, because I can see all those the 2 is a common factor of all 3 of those terms. Have x squared plus 6x plus what? 2 times what? 5. So now I have that guy. Nothing cancels. So what I have to do here is I have to factor the top again. I have to factor the bottom. So I see this. If I did the AC method, and sometimes you can bypass the AC method, but to factor the top, I'm going to do this AC method. A times C is equal to 9. A plus C is equal to, well, that's easy, 9 and 1. 9 and 1, so let's rewrite this fraction here. Let's go here, and this is going to be, here's the top. It's going to be, since A is 1, I'm going to go right into the factorization. X minus plus 9, sorry, and X plus 1, and that is the factorization. 9 plus 1 is 10. 9 times 1 is 9. Very good. So let's see if we can factor this guy right here. Looks like the same thing. Because if I did the AC method on this guy right here, A times C is equal to 5. And A plus C needs to equal 6. And right away, I see those numbers are 5 times 1 and 5 plus 1. And since A is 1, I can go right to my factorization, which I'm going to do. And let's see here. It's going to be x plus 5 and x plus 1. Does that expression have like, it does indeed. it has these factors here. Who would have thought that? Well, hopefully some of you did. But anyway, these things factor. Circle them, go. Those are gone. Those become 1. And what is my simplified rational expression from that? I simply write it as 3 times x plus 9 divided by 2 times x plus 5. That, ladies and gentlemen, really, if I'm not mistaken, this problem right here is a problem that you will see in the challenge zone for this IXL. And I would go ahead and ask you to try a couple challenge zone problems. I probably will let you, and I'll probably have you go to about a 92 today on this IXL, just so we can do a couple of these challenge problems. I got to tell you, this is going to be a very, very important lesson. I was looking ahead at a future lesson of adding fractions, adding rational expressions, and that's kind of difficult. This isn't too difficult, so good luck to you. And all I can say is God bless you. May God bless and keep you. And I will see you soon. Out.